All right, good morning, ladies and gentlemen. Today we are going to be reviewing wave properties. Okay, these are terms such as amplitude, wavelength, frequency, energy. Okay, these are all things that we are going to be reviewing today. So remember with a wave, waves specifically transfer energy from one place to the next through something called a medium. Okay, remember, medium is just the matter that a wave can send its energy through. Okay? So if we look at our objective, it says I can use computational thinking to describe a simple model for waves that shows the pattern of wave amplitude being related to wave energy. Okay. So before we hop into this, let's recap parts of a wave. This will be important when we get to our assignment today. Um, let's look at a standard. This is what we call a transverse wave. It's transverse because energy moves left to right, while matter moves up and down. Okay, so if we recall, waves transfer energy. Okay, so when there's no energy being moved through this medium, we'd be back at sea level. We'd be at what we call resting position. Okay? But as we send energy, we can send a wave through it, and we can notice that we can create this wave pattern. Okay, so it's important to know waves only transfer matter, they do not transfer energy. So as this goes up right here, when it goes back to its resting position, it's going to return to the same spot that it started. Okay, so let's look at a couple parts of a wave. We have what we call the wave crest. That is the highest point of the wave. We have the wave trough, which is the lowest part of the wave. We have this amplitude measurement, and this one's going to be really important because amplitude shows us how much energy there is in the wave. And we'll look at that in reference to light and sound in just a moment. But amplitude is the measurement from this resting position up to the crest. This measurement could also be from the resting position down to the trough. Okay, these measurements should be the same. Okay. We also need to know the wavelength. Okay, and the wavelength is just the length of one wave. And you can measure the wavelength from crest to crest. You can measure it from trough to trough, or you can measure it from the start of one wave to the start of the second wave. Okay, and those are all parts that we can measure the wavelength. Okay. So one other word I want to look at is right over here called frequency. And frequency is just how many waves there are within a certain time period. Okay, if you have a lot of waves, that's said to be a high frequency. Okay, notice that a high frequency wave is a short wavelength, whereas a low frequency wave is going to have a longer wavelength. So those two are said to be inversely related. Okay, so let's apply this concept to things that we can see and things that we can hear. Okay, remember the energy in a wave is directly related to the amplitude. Okay, so a bright light has a lot of energy. It has a high amplitude. Whereas a dim light is going to have low energy and have a low amplitude. Okay? If we talk about frequency, okay, if you have a higher frequency light wave or electromagnetic wave, it can change the color that you're going to see. So higher frequency in terms of the visible light spectrum, it's going to be more violet. Whereas the lower frequency in the visible light spectrum is going to be more red, the colors that you're going to see. Okay, so you could have a very bright purple sight if you have a high amplitude, high frequency. It's kind of cool. Okay, same concept can be applied to sound. If you want to have a loud sound, you got to put a lot of energy into it. Remember, we dropped masses into water and made splashes. The more potential energy you gave it, the bigger the wave. So more energy, higher amplitude. Okay, we could have a soft or a low amplitude sound wave, and that would be quiet. Very cool. Okay. With that being said, frequency is related to the pitch of the things that you hear. A high frequency sound wave is going to be a high pitch, whereas a low frequency sound wave is going to be a low pitch. Okay, so by altering these properties of a wave, you can change the things that you see as well as the things that you hear. Okay? So let's take a minute really quickly and let's look at our assignment for the day. So today we're going to be dealing with the waves on a string simulation. Okay, it's important that we follow the instructions. You're going to want to turn on oscillate, turn the damping to none, and select no end. So what I mean by that is you're going to hit oscillate, turn on no end, and you can turn your damping to none. Okay, you can go slow motion if you want. And we're just going to observe waves. Okay, first thing you're going to do is you're going to increase the amplitude. By increasing the amplitude, how does that change the wave? Okay, if you have low amplitude, how does that change the wave? Okay, then you're going to start messing with the frequency. If you have a high frequency wave, okay, remember high frequency is a shorter wavelength. Lower frequency is a longer wavelength. If you want to get specific, you can use a ruler, but I will not require it. Okay. And then there's just a couple of questions that I'd like for you to answer. Okay. I hope this made sense. If you have any questions, don't be afraid to send me an email. I will be checking them from time to time. All right. Thank you very much. Bye.